Venera je naša misteriozna komšinica, jedan čudni svet gde sunce izlazi na zapadu i zalazi na istoku, a jedan dan traje duže od godine. Nekada su Venera i Zemlja bile sestrinske planete. Nastale su u istom delu sunčevog sistema, imaju iste osnovne sastojke, iste gasove, isto kamenje koje se vrtelo po ranom sunčevom sistemu. Ipak, ove dve planete su imale potpuno drugačije sudbine. Šta se dogodilo Veneri pa je postala ovako pakleno mesto? Misija Evropske svemirske agencije Venera Express je provela poslednjih 8 godina sakupljajući podatke kako bi ponudila nauci jedan novi uvid u atmosferu i klimu ove planete, uključujući i smelo aerokočenje koje je ovog leta dovelo do otkrića do tada nepoznatih talasa u gornjim slojevima atmosfere. Evo šta do sada znamo o Veneri.
Hello and welcome to Space, here from the Observatory of Paris, where we're taking a close look at our planetary neighbour, Venus. A strange world where the sun rises in the west and sets in the east, and a day lasts longer than a year. But first, let's have a look at some more news from the universe this month. Two probes have just reached Mars, NASA's MAVEN spacecraft, which will study the atmosphere, and India's Mars orbiter mission. This is a new 16-lens telescope conceived by a consortium from Poland, Italy and Romania. It will spot previously unknown asteroids close to Earth. And ESA's astronaut Alexander Gerst has been developing new vaccines on the ISS by examining how salmonella microbes become more virulent in microgravity. And now to Venus, a planet which has entranced scientists for centuries. Founded back in 1667, the Observatory of Paris has seen all manner of new ways to study the solar system, including a raft of devices to watch Venus pass in front of the Sun.
Ici, nous avons un exemplaire unique.
This is a unique example of Jansen's revolver. This instrument was designed at the Observatory of Paris to observe the transit of Venus in 1874 and 1882.
Today, the Observatory of Paris remains at the cutting edge of planetary science, and it's home to Thomas Wiedemann, a specialist who spends his time trying to solve the puzzle of the planet Venus.
Venus et la Terre sont comme des planètes.
Venus and Earth are like sister planets. They were formed in the same part of the solar system, even closer than Earth and Mars are, with the same basic ingredients, the same gases, the same rocks that were spinning around the early solar system. And yet these two planets had completely different destinies.
So Venus began more or less like Earth, but now it's bone dry and cloaked in a thick, choking atmosphere of sulfuric acid and CO2.
It has a very dense atmosphere, to 97% of carbon dioxide, a very strong greenhouse effect, and the temperature down on the surface is more than 450 degrees Celsius. And the surface pressure is 92 bars. It's almost 100 times more than the Earth. So it's a very, very unpleasant place to be.
Unpleasant and also unusual, this is the only planet which rotates clockwise, and there's more.
Venus is the only planet in the solar system that needs more time to rotate once around its own axis than it rotates around the Sun. So it's 243 days for one Venus day, and it's 224 days for one rotation around the Sun.
In 2005, ESA launched the Venera Express spacecraft to have a closer look at this oddball planet. After 8 years of scanning the dense clouds below, the team sent Venera Express skimming into the top layer of the atmosphere, a technique known as aerobraking. Don Merritt from ESA's base near Madrid explains.
We went into the atmosphere in this direction because this face of the spacecraft, which had been attached to the rocket originally when it was launched, was most able to take the forces and the temperatures. We also turned the solar panels to maximize the amount of friction and to get the most amount of braking in this kind of gold foil.
The aerobraking maneuver offered the first ever close-up view of Venus's upper atmosphere, and it wasn't what was expected.
What we saw that was a little unusual is the variability in the pressure, as if there were waves within the atmosphere. And so that possible wave-like structure was not expected, and analyzing that data will keep scientists busy for a little while yet.
The science team has another puzzle from the Venus Express data. They've noticed that the Venusian winds are getting faster.
When we arrived at Venus 8 years ago, we detected winds at 300 kilometers per hour, very fast. But what has happened during these years, until now, they have actually increased. We now see winds of 400 kilometers per hour. And we can't really explain why that has happened.
Yet more riddles lie in the landscape of the planet. One of the very few photographs of the surface of Venus taken by Russian probe Venera 13 shows no sign of volcanoes, but plenty of volcanic rock.
La surface de Vénus est relativement
The surface of Venus is relatively young on the scale of the solar system. And there's a contradiction for us between the absence of volcanic and tectonic activity today and this surface, which, despite everything, appears quite young. So maybe there are some rare, powerful and violent geological processes that could resurface the planet in a catastrophic way, creating a kind of rebirth of the Venusian crust.
So, what could possibly have happened to Venus to turn it into such a hellish place? There are some theories, if not yet proof.
There must have been a major disaster in the early history of the planet where it collided with a big other object. And this made it stop its rotation. And I think this was really the turning point in the life of Venus.
Clues as to what happened in the past may yet be found in the vast amounts of data gathered by Venus Express, and Venus itself will continue to entrance and surprise.
Venus est la planète la plus brillante du ciel.
Venus is the brightest planet in the sky. It's the brightest light after the sun and the moon. It's a planet that's part of our cultural heritage. So it's this special personality of Venus as a shining cultural object that attracts me the most. Maybe even more than the scientific reasons we've talked about.
While one spacecraft has a close encounter with Venus, another, Rosetta, is having an even closer encounter with a comet. Let's see how the team are getting on. Now that Rosetta is at the comet, all eyes are on Philae, the lander, which will touch down on the comet's surface in November. Here at ESA's Astronomy Centre near Madrid, Larry and Michael manage which instruments do what and when.
So what's up? Well, I've seen something on the elevation camera. The tricky bits are the unknowns, of course. Every day it's an object which is coming alive. Every day it's producing more gas, more dust.
The landing site has now been selected, and of course we all hope that it will be successful, and it is clear that it is a risky business, but I think it will be a success.
The landing itself is a huge event. We separate the lander at a certain distance. It says bye-bye to the mother craft, which has brought it so far. And within about an hour or so, it starts uplinking the images. So, of course, getting the signal from the lander will be very important. Hey, Rosetta, you may be hundreds of millions of kilometers from here, but don't worry, you're not going to crash into the comet because we know exactly where you're going to go. Keep working, keep alive, and keep sending those beautiful data to us, beautiful images.
Rosetta, well, it was a long journey, but now you are there. I trust in you. We'll have a great journey till the end of the mission.
Ispostavilo se da je Pluton mnogo čudniji nego što je to iko očekivao i da njegova površina krije razne neobjašnjive fenomene. Stupili smo u kontakt sa nekim od najboljih evropskih stručnjaka za ledenu planetu kako bismo otkrili da je Pluton bio i ostao misterija od kako je otkriven 1930. Prvo je nazvan planetom, a onda ipak klasifikovan kao patuljasta planeta 2006. Što više saznajemo o njemu, to on više budi maštu naučnika kao što je Elliot Sefton Nash iz Evropske svemirske agencije.
Hello and welcome to space, and this month we're taking you out to the furthest reaches of our solar system, to this place, the dwarf planet Pluto. It turns out to be far more weird than anyone ever expected, with all kinds of unexplained phenomena on the surface. We sought out some of Europe's finest ice planet experts to find out more. Pluto has been a mystery since it was discovered in 1930. First called a planet, then reclassified as a dwarf planet in 2006, the more we learn, the more it captures the imagination of scientists like ESA's Elliot Sefton Nash.
One of the important things you should understand about Pluto is the real scale of it compared to the rest of the solar system. So we've come to the beach to really convey that scale and distance. So if I draw the sun as a 30 centimetre circle, then we have to walk about 35 steps this way in order to draw the Earth in the same type of scale. So the sun is over there at 30 centimetres, which means that the Earth should be about here, about 3 millimetres, something like this. If we were to draw Pluto in the same scale, it should be 0.3 millimetres, and it should be 1 kilometre down the beach. Now obviously I can't draw something that's 0.3 millimetres, so I have to draw Pluto a bit bigger. If this is Pluto, then its largest moon is Charon, which is about half its size. But Pluto has 4 other moons: Styx, Nix, Kerberos and Hydra. So there's a lot going on around the Pluto system. It's not just a cold, dead, icy rock.
Humanity had its first close-up view of Pluto in 2015 when NASA's New Horizons probe flew past the dwarf planet and its moons. What it witnessed was unlike anything we'd ever seen before. Scientists working on New Horizons like Bernard Schmidt and Tanguy Bertrand were spellbound. They were seeing a distant world that didn't resemble the rocky planets Earth or Mars, nor the gas giants Jupiter and Saturn. Pluto is different.
When New Horizons arrived at Pluto, we were struck by the topography. Why? Because you've mountains that reach up to 4 kilometers high, and you have this huge basin which is 3 kilometers below the average surface height. Those are enormous topographical differences for a small body like Pluto. The 6 gigabytes of images and scientific measurements slowly sent back by New Horizons are now filling in the gaps in our knowledge of Pluto. What the team is finding as they dig into that data is a world dominated by ice. Bernard and Tanguy took us to a frozen lake near Grenoble and cleared the snow to allow us to compare what we see here on Earth with what has been discovered on Pluto.
The water ice here is close to 0 degrees, like in all the glaciers here in the Alps. So it's relatively soft, it flows and forms glaciers. But on Pluto, this water ice is at minus 230 degrees Celsius and it's as hard as rock. So on Pluto, it's water that forms the mountain ranges.
So the mountains on Pluto are water ice, occasionally dappled with patches of methane frost, while the huge heart-shaped glacier on its surface is made from nitrogen. Scientists think Pluto has strong seasonal cycles too, which could explain some of the unusual features on its surface.
The equator is an enigma. There are no volatile ices, it's just the base of water ice covered in a kind of soot. This black material that's produced by the photolysis of the ice by UV rays. So there's a huge contrast between the dark zones of the equator and the bright areas in the north, and this gigantic glacier of nitrogen ice that's the size of France.
That glacier, known as Sputnik Planitia, is thought to be under 1 million years old, a remarkably young age by planetary standards. Nobody has agreed on an explanation for how it was formed and how it's renewed. Understanding Pluto can really help us understand the solar system as a whole, so scientists think there's a strong case to go there again.
I think it would be fantastic to send a lander to really understand first of all, the structures and the mineralogy up close, but also to observe it over a longer time period. Because we've only seen Pluto in an instant of its orbit. And so the seasonal changes might be very dynamic if we could watch it for a whole year.
It's a strange place, and so you really want to simulate this world, do experiments, try to understand how it works, because there's a kind of climate, there's an atmosphere on Pluto, there are ices, but it's not at all like Earth.
Nobody imagined we'd find such a dynamic planet so far from the Sun. We're left with a lot more questions, but a space mission that poses more questions than it answers is a successful mission.
Just a few years ago, Pluto and its moons were nothing but a few pixels in our telescopes, mysterious dots in the asteroid belt beyond Neptune. Now we know it better, and we're curious to know more.
Away from Pluto now and to our new mini-series, Legends of Space. Throughout 2017, we're celebrating 60 years since Sputnik by looking at some of the greatest moments in space exploration. And this month, we looked at April 1961, when Yuri Gagarin became the first man in space.
Протяжка 1. Давайте, протягивайте. Продувка.
I'm always impressed when I look at the life of Gagarin, how hard a life he had had, and he came from a very modest family. A young man, he was 27 years of age when he did his flight on the 12th of April 1961.
It was an extremely risky operation, and that's what we loved about it back then. I was young, just 24, and it seemed extraordinary. And it was.
Gagarin stands very high in the minds of astronauts and cosmonauts, and in the International Space Station you have a portrait of Gagarin who is there and looking at all of the occupants of ISS.
The risk, the success, and then Gagarin's charisma. He was likable, he was young, he was the son of a potato farmer, so he was perfect for Khrushchev. It was a real demonstration of what a Soviet astronaut could be.
De ce que pouvait être un astronaute soviétique.
Ima li života na Marsu je jedna od onih tema o kojoj ne možemo da prestanemo da razmišljamo. Ili ćemo se naseliti tamo ili ćemo zauvek o tome maštati, treća opcija ne postoji. Ako smo mi kao običan svet toliko opsednuti tom idejom, zamislite kako je astronautima i naučnicima. Njihova radoznalost je beskrajna i zato su pokrenuli ExoMars misiju, koja predstavlja neverovatne naučne i inženjerske izazove dok pokušava da otkrije neke od misterija našeg sunčevog sistema. ExoMars svemirska letelica je već stigla do crvene planete u oktobru prošle godine, ali mi se vraćamo na mesto gde je počela ova avantura. Lokacija: Bajkonur, Kazahstan.
Hello Hello and welcome to space here from the Baikonur Cosmodrome in Kazakhstan. The ExoMars spacecraft has just blasted off from the launch pad behind me on its way to the red planet to go and search for signs of life. It's an incredible scientific and engineering challenge, and we're with the people who are making it happen this year in our special series, Destination Mars.
This is where the ExoMars adventure begins. Baikonur on the Kazakh steppe, the spot where Gagarin first launched to space, and Russia's great history of spaceflight looms large. Gathering at the viewing platform 3 kilometers from the launch pad are scientists and engineers from Europe and Russia. Soon, the precious scientific instruments they've worked for years to develop and build will be blasted towards Mars.
If my instrument is shaken, it will be tormented. And our instrument really doesn't like that kind of thing. But we hope that it will survive.
For about the past 40 minutes, I'm starting to get a bit of a cribble. Starting to feel a little bit edgy. You think of all the people that are putting so much work into it, and you see the people that are here, and then the people that are back home who've put a huge amount of effort into trying to get this thing onto the pad. And it's now what, 5 minutes to launch? Yeah, it's getting a bit nervous.
Wait another half hour and then we know.
The rocket safely skyward, the relief is clear.
Fantastic! We're on the road to Mars. It's been really amazing.
The rocket may have left Earth safely, but there's still a lot to do. A few hours later at the Mission Control Center in Moscow, and there are tense faces again as ExoMars prepares for a tricky maneuver in space. The rocket has to fire its engines 4 times, then separate from the spacecraft.
It's a controlled explosion, that you're executing to some extent, and there's always an element of risk behind it.
The separation goes to plan. Now ESA has to check that everything is working.
We run all the spacecraft tests to make sure that we have the spacecraft fully under control. And then the weeks after, we will start testing one after the other, the instruments, all functions of the spacecraft, the big antenna to communicate to Earth. Everything that can be tested will be done during that phase. And then it just drifts away up to the point that we do the final correction and inject to Mars.
This is the first of 2 ExoMars missions, and it's dedicated to studying the atmosphere, sniffing out methane and sending a small test probe down to the surface. Mars experts across Europe and Russia are watching closely, including here at the University of Lyon in France. One of the big mysteries they want to solve is the presence of methane, which has been found in small quantities on Mars.
The gas we're interested in the most is methane, because methane is not stable in the Martian atmosphere. What is stable in the atmosphere of Mars is carbon dioxide. If methane is released into the atmosphere, we know that in a couple of 100 years it will be transformed into carbon dioxide. So, if there is any, it means that it's been emitted now by the planet.
The scientists will be tracking where methane is emitted on Mars and comparing it with new images that ExoMars will generate.
I studied the surface of Mars. The main instrument that interests me is the camera Cassis, which was made in Bern. This camera allows us to have color images of Mars at a resolution we don't have today, and above all to have the topography, the hills, systematically and in high resolution.
Those images will also feed into the ongoing debate over the presence of salty water at certain times and certain places on Mars.
We haven't really found liquid water on Mars. We found traces of salts which were deposited by liquid water. But we're not talking about cooking salt here. It's more like a salt, like the salt you'd put in water to make bleach. So it's not something that's very favorable for life.
When ExoMars reaches the red planet in October, it will split up, the main spacecraft staying in orbit, while its small lander, called Schiaparelli, will head for the Martian surface. It's a surface that may look like Baikonur, but is very different, far colder and drier. Exactly how different will be explored by Schiaparelli.
The opportunity to have a probe going down through the atmosphere allows us to have local measurements of the atmospheric conditions, and this allows us to understand how the climate of Mars functions.
Meanwhile, high up in orbit, the spectrometers on ExoMars, one of them developed by Oleg Koroblev, will take fine measurements of the Martian air.
Our instrument is devoted to the measurement of trace gases by measuring the solar radiation passing through the atmosphere of the red planet.
All these different measurements will feed into the core scientific questions. Is there life on Mars now? Was there life on Mars in the past?
You could think it's a dead planet, but in fact things happen, and especially there are changes that involve water, which is the first ingredient of life.
It doesn't look habitable, but that doesn't mean it isn't inhabited.
If methane is there in abundance and you see it locally, it doesn't have to be biology. And it's important to recognise here that I'm a little bit of a skeptic. You know, I don't go for this life business. I try to keep the other guys honest.
To bi bilo sve za danas. Hvala vam što ste zajedno sa nama krenuli u još jedno putovanje svemirom u emisiji Space Show. Pratite nas i dalje i pišite nam u komentarima da li i vi maštate o preseljenju na Mars.